Hello, class. So, in today's lesson, my goal is to kind of expose you to different ways of how we solve logarithmic expressions, okay? Combining the properties and the laws and change of base, all right? So, I'm going to go in that mode. I'm going to do some properties, going to do some logs, mix it with some properties, and then do a change of base. It's going to be a little lengthy because I'm trying to let you see different things, all right? And if you practice, it becomes more easier for you when you see a different scenario and you're trying to apply the properties, all right? So bear with me as we go through this, okay? All right, so I have listed above the properties. So get used to them, memorize it, know how to use it. I mean, you studying this at home, so you can always reference your notes to also see what these properties and laws and change of basis are. But I have them right here, and we'll reference them if we need to. So let's look at the very first one. So the first one is more or less properties. So let's look at what the answers are going to look like. So ln e raised to the 9, the base is e, so here the answer is what? Is 9. 5 raised to the log of base 5 over 2, the answer is going to be what? Root 2. And then e raised to the ln of 10, or the base is e, so we end up getting just 10. And then this over here, I can apply the laws and actually drop this negative 3. So we could have done this in so many ways. You could just looked at it and go, to what power should you raise 5 to give you 5 to the negative 3? That's just negative 3. Or you can see that you can also drop the power in front of the log and it becomes negative 3 log 5 of 5. And you can apply the property over here that if you have a log of the same base of the same base, then that is just what? 1. So they become negative 3 times 1, which is what? Negative 3. So in question 4, I applied a mixture of the log and the properties to help me do this. Now let's look at this. This is where things get interesting. So the goal is I need to expand. So you realize that in the properties, two things happened over here. If you have a product of terms, we're able to expand it over addition of each of the factors in that product. And then if it was a quotient, we're able to expand it over subtraction, or the difference of the numerator and the denominator. And if it was something raised to a power, we're able to drop down the power in front of the log. So my goal over here is I need to see what's going on over here. So log AB seems like it's a product. So I can expand by writing this as log A plus log B. Over here, we're working in base 10, so that's why we didn't have any base. You don't see the base over there. Now, when I come over here, then question number 2 says log of x y squared. I see a product of two terms, all right, or two factors. So I can rewrite this, expand it as log x plus log y squared. But I can leave my answer like this because one of the properties is the power rule. Says that if I have an argument raised to a power, I can always drop down the power. So I can further simplify this to give me log x plus dropping the power 2 down, I get 2 log y. Okay, now let's look at the next question. The next question says log base 7 of a quotient, 49 over y. In this case, I see the quotient rule over here. I can split this up, expand it over subtraction, so it's going to get log base 7 of 49 minus log 7 of y. Well, I wish I could leave my answer like this. So always try to look at what you have and see, is this the most simplified version of your expansion? When I look at the very first term, it looks like, to what power should you raise 7 to give you 49 is going to be what? 2 minus log 7y. Okay, you could also see this. You could have written this as log 7 squared and applied the power rule to give you 2 log 7, and that is also what? That's also 2. So that's another alternative to solve that first term. But you could certainly use the intuitional definition that we came up with. To what power should I raise 7 to give me 49, which is 2. Now let's look at the next question. So the next question, question 4, says I have log 3 of 27 times root x. All right. So over here, I see a multiplication. So I'm going to split this up into 2 logs over addition. So I get 27 plus log 3. And I see that the square root, I can write it out as a rational exponent. So I get to the 1/2. Now, I can leave my answer this way. I can still clean up this expression over here. So I can see that log 3/27 is the same as log 3 to the cubed plus, and I can also drop the power in front, so I get 1/2 log 3 of x. So my final answer, well, to what power should I raise 3 to give me 3 cubed, is 3 plus 1/2 log 3x. Okay, hopefully you see the trend. You see where things are going. Let's look at the last one. Well, this question, question 5. We get, I can split this up to give me 3x cubed plus log 3 x squared minus 1. All right, and I can apply the power rule on the first term. I can drop the 3 in front so that this becomes 3 log 3x plus, and then the square root, I can rewrite that as a rational exponent. So that becomes log 3 x squared minus 1 to the 1/2. And I can see also that I can drop this power in front over here. So my final answer would be 3 log 3x plus 1/2 log 3 x squared minus 1. All right. So as I'm doing this examples, make sure you have a copy in your notes so that when you're trying to figure out how to manipulate certain expressions, logarithm expressions, you can always go back and look at, oh, it's like this is what I had to do to clean this up. Okay, so let's look at this complicated one over here before we move on to the next thing. So it looks complicated, but we can still solve it. So I'm seeing a quotient in the argument. The argument has a bunch of stuff in the numerator divided by a cube root. So the big picture is this is a quotient. So the quotient rule says that I need to split this up over subtraction. So I get x cubed times x minus 3 minus log cube root of x plus 1. Well, I can leave my answer over here. So if I look at the term, the log expression on the left, I see a product. So I can further expand this. And if you further expand this, you end up seeing that this is log base 4 of x cubed plus log base 4 x minus 3 minus, and I have a cube root that I can rewrite as a rational exponent. So I get log 4 x plus 1 to the 1/3. Well, I wish I was done, but I can still simplify this. I see some powers over here, so I'm going to use my power rule to help me clean up this expression into its simplest form. So I see that I can drop the 3 in front, so I get 3 log 4x plus log 4 x minus 3, and I also see a 1/3, which is a power that I can drop down. So I get log 1/3 log 4 x plus 1. So this is as hard as I can get. All right, so I started pretty easy and built some momentum to get to this point over here. Okay, all right. Oh, we do have one more. Oh, with an ln. All right, so let's see how this breaks up. So over here, this is ln x minus ln e to the 3. Well, this can clean up a little bit. I can drop the 3 in front. I get ln e, but ln e means something. So if you go back to our properties, I didn't write it out, but if you look at the previous notes, you can see that ln e, we're asking ourselves, to what power should we raise e to give me e? That's 1, so this really cleans up itself. Ln e is equal to 1, so this cleans up itself to ln x minus 3. All right, so let's look at these interesting questions over here, and there are 4 of them before we move on to combining. It says that we have an ln 2, which is equivalent to a, and ln 3, which is equivalent to b. And they want us to write ln 12 in terms of a and b. So I'm looking at 12, like, how am I going to get 3 and 2 in this? So you got to think about what are some factors of 12. Well, some factors of 12 are 1 and 6. No, not 1 and 6. 1 and 12. You could do 2 and 6. All right, you could also do 4 and 3. So I'm looking at some product of numbers or factors that result into 12. That will allow me to use ln2 and ln3. All right, so I'm going to start off with using ln 4 times 3, right? Because that's 12, all right? And then I see that this is a product. So if that is a product, that cleans up nicely as ln 4 plus ln 3. Well, I don't have ln 4. However, 4 can be written as 2 to the squared. So I want to change that 4 back to something that I can recognize in my setup over here. So this ln 4 is the same as ln 2 squared plus ln 3. Now, my properties, my power rule properties tells me that I need to drop that 2 in front of the ln. So this becomes 2 ln 2 plus ln 3. Now I can clearly see ln 2 and ln 3 in my work. I can make a direct substitution now. So I end up getting 2a plus b. Okay, let's look at the next question. So the next question 2 says ln 2 divided by 3. Well, it's a quotient, so I can apply the quotient rule. So it says ln 2 minus ln 3. This is very straightforward. You already know what ln 2 represents. So this is the same as a minus b. Okay, let's look at something like this. So this is the same as you writing. Question 3 says ln 4, the fourth root of 3, means I can rewrite this as ln as an exponential rational exponent that is the same as 3 to the 1/4. And I can rewrite by dropping the power down, which is 1/4. So I get 1/4 ln 3. And I know what ln 3 is. Ln 3 is equal to b. So I end up getting 1/4 b. Now let's look at 36. So 36 is equal to, you can think about 36, some nice factors are 4 times 9. And I like that because 4 is 2 times 2, and 9 is 3 times 3. So I really kind of split this up nicely as ln 2 to the squared coming from here plus, well, let me not be too quick. Let's split this up nicely. So initially, this is the same as ln 36 plus ln e to the cubed. All right, and we just discovered 36 can be broken down as ln 2 squared times what? 3 squared plus. And I can drop the power 3 in front of the ln, so I get 3 ln e, and ln e is equivalent to 1, so that times 3. And then over here, I can see another product. So I can split this up as ln 2 squared plus ln 3 squared plus 3 times 1. Well, I'm not completely done because I do see some powers. So those are going to drop in front. So I end up getting 2 ln 2 plus 2 ln 3 plus 3. So my final outcome is going to be 2a plus 2b plus 3. Okay. All right. Almost halfway through. All right. Hang in there with me. All right. So the next thing we can do is, since we can combine, we can expand. Since we can expand, that's what we did earlier on, we can also combine. Meaning that you might have terms of logs, and your job is to kind of compress them or combine them back into a single log. All right. So I want us to pay attention to the properties, right? Let's look at the properties one more time. So you can clearly see that if you look at the product, the coefficient on the product expansion is 1, all right? In the quotient expansion, which is the difference, the leading coefficient on the logs are 1. It's only the third one that has a coefficient of c, which you know where it came from. It came as a power, so you can always return things back. So our job is, as long as the quotient and the product, its expansion is not 1, the leading coefficient is not 1, your job is to return it back to 1. So that means that if you see a coefficient other than 1 in front of a log expression, you are required to what? Return it back to what? Back to the power before you can start either multiplying for the addition or dividing for the quotient. All right. So we'll do some examples and you see what I'm talking about. So if I go all the way back here and I'm trying to combine them, so I can see that the leading coefficient here is 1. That is also 1. So I am feeling comfortable that I can combine this. And I see an addition that is telling me that it came from a product. So what product did it come from? It was log 6 of 2 times 3, which is log 6 of 6, and that's a property that we can rely on, which is equal to what? 1. I have a base raised to an exponent, but the exponent is expressed as a log. So I can see that this is 10, and I'm seeing that, okay, again, the coefficient is 1 and 1, so I'm feeling good about myself. The operator in between is a subtraction, so it's telling me that I need to divide 8 by 2. All right, so this is going to be log 8 divided by 2, which gives me 10 log 4. Well, remember that it's got an invisible base, so this is another property. So 10 raised to the log of base 10 of 4, the outcome should be what? Should be 4. Okay. We're still trying to combine things. And in this case, when we did the first two example, things simplified out. Now let's look at the third scenario. So the third scenario, I have log 4. And again, I got a subtraction, which is telling me I need to divide m over n. And then the leading coefficient is 1. That is 1. So I'm feeling very comfortable about it. I can just equally do 20 divided by 5. So I get log 4 of 4, which is equal to 1. Okay. How do we simplify this? Well, the leading coefficient is not 1. So how do I make it 1? I need to return this back to the power. So this is the same as log 3x cubed. Okay. We have this expression over here. I'm trying to add, so I see that I need to do a product of m times n. The leading coefficient is 1. The leading coefficient is 1. So I'm feeling pretty good right now. This is going to be log base 4 of 32 times 2, which is equal to log 4 of 64. And I ask myself, to what power should I raise 4 to give me 64? And that is 3. Let's look at this expression here. So I have a division. Well, I have a subtraction rather, sorry. The leading coefficient again is 1. The leading coefficient is 1. So in this case, I can see that I need to write log 5, and it's a subtraction telling me that this is supposed to be a quotient. So I'm going to divide 2y minus 1 over what? Over y. Okay. All right, let's look at the next question. So the next question has a combination of plus and minus. So reading from left to right, I can clearly see what's going on with the first two. So the first two is telling me that I have an addition. Well, the leading coefficient over here is 1, but this is not. That means I need to return it back to the power. So in that sense, when I combine the first two terms, I'm going to get log 2a plus log 2b to the 4. And if I kind of continue again, the subtraction is telling me that I'm going to divide, but I need to work the first two first, combine it, because it's what? It's an addition. So this gives me log 2 of ab to the 4. Now, if I join the rest to it, it says minus 1/2 log 2 x minus c. So you're always reading from left to right, and as long as the coefficient is 1, that is okay. If it's not 1, you need to return it back as a power. So I've combined the first two logs because it was an addition. So I put it back as a product, and then I continued the problem with the negative 1/2 log base 2 x minus c. Now I see a subtraction, which is telling me that I have a division to make between the first argument and the second argument. So if I do that, I end up with, well, before I do that, I almost missed it. I need to return the 1/2 back as a power. So that would be log 2ab to the 4th minus log 2 square root of x minus c, because I get a half at the top. So now I'm ready to what? To do the quotient, because now the coefficients are all 1 now. I'm feeling pretty good now that I got everything in control. So now if I combine, I end up getting log base 2 of ab to the 4 over the square root of what? X minus c. Okay. All right, let's look at some harder ones. So here, order matters, parentheses. So I'm going to deal with the thing that is inside first. And then I'm going to apply whatever is outside to whatever I get as a single log. So again, the coefficient in front of log x is not 1, so I need to return it back to the power. So this will become 1/2 log x cubed plus log y. Now that everything is back to a coefficient of 1, I am feeling good. I can combine them because it's an addition. So I'm looking at the product of m times n. So I end up with 1/2 log x cubed y. So I've resolved what was inside the parentheses. Now all I see is 1/2 log x cubed y. This 1/2 needs to return back to a power. So this whole thing is in parentheses, okay? Back to a power. So the final outcome is going to be log x cubed times y, all raised to the what? 1/2. You can also write it as a square root, so it becomes log square root x cubed y. Okay, let's look at the last one. It says that I'm subtracting, so I'm seeing that I need to do the quotient. The leading coefficients are 1 and 1, so I'm feeling really good that I can easily do the quotient. So I'm going to log 8, and then I got x squared minus 1 over x plus 1. Well, I can leave my answer like this because I can simplify. So my final answer is log 8 x minus 1 x plus 1 divided by x plus 1. These two cancel out, so I end up with log 8 x minus 1. Okay, all right, the last thing we need to look at is change of base. So it says using your calculator, you can do a change of base and evaluate it. So over here, I could do a change of base either in base 10 or base e because I have it on my calculator. So my change of base is going to be ln 10 divided by ln 2. So if I pick my calculator, I'm getting ln 10 divided by ln 2. I get 3.3219. Over here, I'm trying to figure out this. I'm going to work in base 10. Hey, I'm going to get log 3 divided by log 8. And I have a log feature on my calculator, so I'm going to get log 3 divided by log 8. I get 0.5283. And the last one I have is, you can decide to do, let's do ln. All right, so we end up getting ln 9 divided by ln 1/3. And I'm doing this just for the fun of things. So ln is the same, so this ln 9 is the same as ln 3 squared over, and then ln 1/3, I see a quotient. 1/3 is a quotient, 1/3. So I can split it up as ln 1 minus ln 3. Well, ln 1 is one of the properties that we know. That's going to go to 0. This, I can apply the quotient, the power rule property. So this becomes 2 ln 3 over negative 3 over negative ln 3. So this cleans up nicely as minus 2. All right,